This is my third video on how to integrate rational functions. A rational function is a quotient of polynomials. In this video, I will attempt to integrate this function. I want to find an antiderivative for the function 3x plus 7 over x squared plus 4. This is a quotient of polynomials. Based on the last two videos, there are a couple of things we can do to try to simplify it first. We could try to use long division to reduce the degree of the top, but there is no point in doing that here. The numerator has degree 1, the denominator has degree 2, so there is no more division to do. Second, we could try to factor the denominator. Unfortunately, x squared plus 4 is an irreducible quadratic. There is no point factoring it. So that's it. Okay. The key step then is that we have to rewrite this fraction in terms of other fractions that are easy to integrate, the simpler fractions. And the surprise is that in this case, it may not be apparent, but that's already done. I'm simply going to rewrite this as 3 times the integral of x over x squared plus 4 plus 7 times the integral of 1 over x squared plus 4. And my claim is that these two functions are actually short and easy to integrate, and therefore no need to try anything else. So let's look at them one by one. First, I'm going to look at x over x squared plus 4. In this case, the key observation is that I have this x at the top, which up to constants is the derivative of the bottom. So this suggests that I have to try the substitution u equals x squared plus 4. Because in that case, du will be 2x dx. And then, as I said, up to constants, I have what I need for the differential. So that makes the integral easy. The top now becomes 1/2 of du, and the bottom becomes u. So an antiderivative is 1/2 of logarithm of the absolute value of u plus an integration constant, and that is 1/2 of the logarithm of x squared plus 4 plus an integration constant. I can get rid of the absolute values because that's always positive. So that's how I deal with the first one. Now let's look at the second. Next, I want to integrate 1 over x squared plus 4. There are a couple of ways to do this. Some people like to use trigonometric substitution, and you can try that and it will work. I think there is something simpler to do. This integral reminds me of another one that I know how to do. It reminds me of the antiderivative of 1 over x squared plus 1, which I know is arctangent. So because of that, what I'm going to try is to rewrite this one so that it looks like this one. So instead of a 4, I want to have a 1. And I can do that by factoring a 4 from the denominator. And this is going to suggest a substitution. If you don't see it yet, let me first group the x squared over 4 as x half squared plus 1. And now that I have it this way, I think I'm going to take the substitution u equals x over 2, because that will make this the variable, and then this antiderivative is exactly equal to the one I already know how to do. If I try that, then du is going to be 1/2 of dx. And now let me perform the substitution. I'm going to have 1/4. Dx is 2 du, and at the bottom I have u squared plus 1. And this comes out to be 1/2 of arctangent of u plus the integration constant, and finally undo the substitution.